Hi, I'm Dr. Michelle Peace. I'm an associate professor in the Department of Forensic Science at Virginia Commonwealth University. I'm the former president of the Society of Forensic Toxicologists, and I've been funded since 2014 to study electronic cigarettes and the impact of vaping on the criminal justice system, and as well as the public health and generally public safety. I would like to thank the NDUS Network for this opportunity to give an update on the current state of vaping devices and e-liquids. This video will be posted on the NDUS Network, and I will respond to your questions through the NDUS Network in their online forum. I appreciate you tuning into the NDUS to view what I consider are some of the most pertinent issues regarding the current public health and public safety epidemic that we're experiencing. I am funded by the National Institute of Justice. I've had 4 grants through them since 2014. And I'm currently funded to evaluate the impact of vaping ethanol, particularly on standardized field sobriety tests. Otherwise, even though I will be mentioning several products through the course of my presentation, I have received no funding from any other source. Through the course of this presentation, I will be discussing a number of things with regards to electronic cigarettes themselves. I'll describe what e-cigarettes are and how they work, what their multiple generations are, what e-liquids are, and the number of components that are included in e-liquids. I'll discuss a little bit of the analytical work that we've done in my research lab. I'll then discuss some of the literature in terms of what has already been published with regards to cellular toxicity and tissue impact. And then at the end of the presentation, I will be discussing the importance of understanding vaping behavior and the culture around e-cigarettes and vaping. So the first thing that I believe very strongly that we have to appreciate is some fundamental premise that electronic cigarettes have been promulgated for years as being a safer alternative to traditional cigarettes. They use FDA-approved ingredients. They are non-combusting, meaning that there is no fire associated with those. They do not contain tobacco in a traditional sense, and therefore also have no tar. However, they do contain nicotine predominantly. And there has been some premise that they will not lead to cancer. So we see in the GIF that's running here, an electronic cigarette works by the person depresses the power button on the side of the device, and a charge from the battery goes to the coil. That coil then heats to several hundred degrees Celsius. That coil is in contact with the e-liquid, which then generates a condensation aerosol, which is then delivered to the person who is vaping. I'll be referring to the temperature of the coil later in my presentation. It is important to appreciate that there are several generations or iterations of electronic cigarettes as we have known them in recent years in the United States and worldwide. Electronic cigarettes actually have a very long history, particularly here in the United States. But when we think about electronic cigarettes and their current impact, you have to think about the first generation starting as what is referred to as the cig-alike. This is a closed container system that is a single low voltage with a small concentration of e-liquid on the inside of it. Once a user consumes all of the e-liquid in this e-cigarette, they then dispose of the cig-alike and then get another one for their next usage. The first generation quickly evolved into second generation e-cigarettes called mid-size or pen-like. And these e-cigarettes are predominantly meant for to allow the user to manipulate their device. The first manipulation that was important for their consideration was them wanting to put in their own e-liquids and not necessarily dispose of a cartridge. So they contain these large tanks to hold large volumes of e-liquids, oftentimes up to 5 milliliters. The atomizers themselves came in a number of generations, from having the sponge-like filling to these empty tank systems that they could fill. These things were also came with rechargeable batteries so that the user didn't have to dispose of their e-cigarette after they consume the e-liquid. Second generation fell away to the third generation, called the advanced personal vaporizers. The advanced personal vaporizers are classically known to be completely customizable by the user. They have large battery packs on them in which an operator could choose from a range of voltages or wattages depending on the electronics display on the battery. And they also allow the user to wrap their own coils, use their own kind of wicks. And so what we saw with these is that as users became more advanced in how they use the electronic cigarette, they were searching for more ways to use the e-cigarette, particularly when thinking about vaping drugs other than nicotine. So in my lab, we then characterize those products as fourth generation or alternative vaping products. And these products take on a range of different sizes and configurations. One of the first things we began to realize was that when you look at the third generation e-cigarette, one of the things that we realized people were doing were dropping the e-liquid directly onto the hot coil or putting a wax or dab directly onto the hot coil. So enter in the fourth generation. The fourth generation allows the user to drop the e-liquid directly through the mouthpiece, as can be seen by the wide bore in the mouthpiece that is on the lower left-hand corner. We also see that products evolved to allow people to vape from substances that were waxy or also dried plant material. What we're currently dealing with are what we consider a fifth generation of electronic cigarette. These are called pod mods. And so, of course, Juul is only one brand in this really wide-ranging assortment of pod mods, or devices that are specifically used for concealment purposes. It's not just that they're small and convenient to use, it's that depending on what manufacturer you talk to, they will admit that these devices are meant for concealment, as they can be concealed in the palm of the hand or easily in their pocket. So what can also be attributed to pod mods is the evolution of the e-liquid into what's called the nic salt. And so the nic salt is a new generation of delivering nicotine to the user, which I'll talk about in a second. In terms of the e-liquid composition, the predominant components of the e-liquid are propylene glycol and vegetable glycerin, or PG and VG. Depending on what the user wants their experience to be, they'll choose either a 50-50 ratio or predominantly PG or predominantly VG. One of the things that has been made aware to us is that people who want to stop smoking will choose more PG in their e-liquid because they say it creates a stronger hit in the back of their throat that is similar to a traditional cigarette. For people who prefer to create giant clouds, then they'll use predominantly vegetable glycerin, or VG. We know that there are a lot of flavorant chemicals that are available for people to use in e-liquids. And there are tens of thousands of chemicals that can be used to create a very specific flavor profiles. We also know that commonly nicotine is the predominant drug of choice for an electronic cigarette. However, what my lab studies are drugs other than nicotine, or the DOT-Ns. We've discovered that a lot of products contain ethanol, and that ethanol is used to either thin an e-liquid or as a solvent for other drugs, or to intentionally vape ethanol. We also have found that a lot of manufacturers are putting in natural products or plant materials, not just cannabis-based material, but also other traditional herbal medicines. We know that there are also people who are putting in herbal supplements, and of course we focus a lot on scheduled drugs and designer drugs in my lab. So in terms of what are PG and VG, we also have some understanding that depending on the manufacturer, depending on the drug that they're putting into the e-liquid, we have discovered that there are also a lot of or some manufacturers that are using PEG or polyethylene glycol. And we also have some understanding that MCT or medium chain triglycerides are also quite popular, particularly for cannabis-based products. And then we also have some understanding that glycerin or glycerol is also used as a carrying agent for drugs. So what we understand is that e-liquid composition range depending on the manufacturer beyond the traditional PG and VG. So let's go back to our Nic salt question. And this particularly refers to pod mods, the devices that are used for concealment purposes. We have a keen appreciation that the pod mods, and particularly the Juul pods, contain more nicotine in them than other devices. And the reason for that is that they're able to combine the nicotine with an organic acid, oftentimes benzoic acid, and this creates the nicotine salt. The reason why they are able to increase the amount of nicotine in the Juul pod is because this organic salt takes away the really harsh hit that just nicotine creates for a user when they vape. One of the things that is also really clear in the literature when you look at toxicity studies, and if you look in this, the lower right-hand corner, is that as the concentration of nicotine goes up, we have more cellular toxicity issues. So Nic salts are leading to more toxic response for cellular tissue. One of the things that we've also discovered in my lab, and one of the really early understandings we gained about the e-cigarette culture was that, and this still remains to be the case to a large degree, is that what is labeled on the bottle in terms of nicotine content often is not what the actual concentration is. So if you look at this chart, the 0 is if the actual concentration matches what is on the label, and we see some wide variation from minus 47% to plus 39%. What we also discovered in our laboratory and published on this, you can see the publication citation in the lower right-hand corner, is that e-liquids contain ethanol. And so what we see here is that in this particular study, 11 of our e-liquids contained more than 10% ethanol. What we have also discovered in recent months is that as we continue our survey of e-liquids, we have also found that some e-liquids contain acetone, isopropanol, and methanol in addition to the ethanol content. And we will be publishing this data soon. So if you look in the literature at cytotoxicity studies, there's plenty in the literature right now and has been for several years, and certainly we're building our literature base on this, where you compare what is the impact of the e-liquid itself to the aerosol on cellular health. And there's also several studies that have looked at different flavorants in particular versus other solvents that are in there. And these are predominantly in vitro studies. I will mention one animal study shortly. So if we take a look at this cytotoxicity study, as opposed to looking at every graph individually, what I do want to draw your attention to is that the number of stars by every individual line indicates increasing toxicity, so, and significant difference. So even if there's just one star, the one star shows significant cytotoxicity compared to the control, and that if we have 3 stars, that shows an even greater statistical difference. So what we see here is that with all of these e-liquids and their aerosols, and these are the different cell lines, is that there is definitely an impact on cellular health with the e-liquids. So if you take a look at, well, what is causing those cytotoxic responses, the question was, is it PG or VG or any of the flavorants? So what we see here, according to this study, is that VG tended to be more cytotoxic than PG, and that these flavorants were more cytotoxic. So those toxic flavorants in that part of the graph are tobacco, mint, and a creamy buttery flavor and the chemicals associated with those. And so it certainly calls to question some of the decisions that have been made to eliminate tobacco flavored chemicals. And so we need to include those as well if we're considering and developing some kind of policy as to what flavorants to ban. So if you also, again, go back to evaluating the e-liquid composition, what we do know is that there are some studies that are evaluating e-liquids only or the aerosol generated from them. And so unfortunately, the data is still mixed as to regarding whether or not one is more of an issue versus another, but it does appear like it is absolutely critical for people to evaluate the e-liquid aerosol itself in terms of its cytotoxic potential. And the reason for that is that there are going to be chemical byproducts as it hits that hot coil that are going to form and then the user will inhale. And those chemical byproducts are things like formaldehyde, benzene, pyridine, and in addition to heavy metals and other chemical irritants. Another important facet that we have to think about with regards to e-liquid composition are flavoring chemicals. Almost all flavoring chemicals are generally recognized as safe. However, they're only recognized as safe for oral consumption, period, not for inhalation. There was a study that took a look at going back through the literature, the published literature, to evaluate what chemicals were being used and had led to a cytotoxic response. And so when they looked at the concentrations of those chemical flavorings, they only found one flavoring chemical that was present at a toxic level. And so it needs to be noted, though, that at some concentration, all flavoring chemicals will have some kind of toxic impact. One of the things that I think we cannot lose sight of is that e-cigarettes also have some metal content to them, whether that is from the atomizer itself, or there are a couple of publications that have demonstrated that e-liquids have trace amounts of heavy metals in them. And then, of course, our coil is also suspect for releasing metals into the aerosol. And so I'm actually going to show you some data that we're preparing for publication right now out of my lab. So we know that there are two predominant wires that are used in electronic cigarettes, a Kanthal wire and a nichrome wire. The Kanthal wire, that amalgam, allows for the e-cigarette, the coil, to get to hotter temperatures. So when we measured how hot the temperature gets, the Kanthal and the nichrome, when these were directly from a dry heating cycle, we saw that the temperatures got in excess of 1,000 degrees Celsius when they were in contact configuration, or the coil was pressed together. In non-contact configuration, as we see this coil here, we see that there's still in excess of 800 degrees Celsius. Now, when these coils happen to be wet with an e-liquid, we see that the temperature is actually more around 250 to 300 degrees Celsius, still hot. When we take a look at how the e-cigarette coil begins to deteriorate, you'll see here, this is under scanning electron microscope. All of these pictures were taken at 2,000 times magnification, and this is the Kanthal wire. So the picture that is on our far left is a new wire. We haven't subjected it to any heat cycles, and you'll see what happens when we heat it once, 50 times, and 150 times. You begin to see a lot of pitting and flaking on that coil, and so there is some understanding and appreciation that that metal is in the condensation aerosol to be inhaled by the user. And so in terms of what metals are disappearing from the coil, we see here, this is our 30 gauge brand new Kanthal wire, and we see that has our iron, the aluminum, chromium, and a different form of iron. And here we see that iron and chromium are disappearing from the surface of the coil. When you turn to the literature and begin to evaluate complaints that vapors have had, you will see very clearly in the literature that people are complaining of irritation to their nasal passages, and that they sneeze a lot, and that they have watery eyes or sore eyes or red eyes. A lot of users will complain of a sore throat or a dry throat, or that they have a heavy cough. What the literature is also very clear about is that there is airway irritation, and that increases as people vape more. There's in the literature as well some documentation that there's some mucus hypersecretion, and that there is an increased inflammatory response. Some of the literature also talks about the exacerbation to people who vape that have asthma or COPD or cystic fibrosis. One interesting manuscript that came out in 2019 from Madison looked at acute lipid pneumonia in mice. And so what we have here are sections of tissue from mice. And what we see here is the electronic cigarette with and without nicotine. And so this is the electronic cigarette. This is just the carrier, PG and VG, and we begin to see that there are these lipid vesicles that are forming in the tissue. And this is with nicotine as well, where you also see these lipoid cells that are forming. So when we take a look at the cases, as of October 1st of 2019, according to the CDC, 1,080 lung injury cases have been reported, as well as 18 deaths. And these are across 48 states and 1 United States territory. When you take a look at the cases that happened in Utah, 6 of their cases had lipid-laden macrophages, as was demonstrated in the mouse studies that I previously described. In North Carolina, they've had 5 cases, and those all had lipoid pneumonia or lipid-laden macrophages as well. Just this past week, there was a manuscript came out in the Morbidity and Mortality Report from Illinois and Wisconsin, and they evaluated 127 cases. They were able to conduct interviews of 86 of their 127 patients in those 2 states. 87% of those patients used THC products, 71% used nicotine, and 58% admitted to using products that had both THC and nicotine in them. So when you look back at some of their earlier cases, and this was also reported in the Morbidity and Mortality Report, is that 14 of their cases had cell counts measured, and 7 of those 14 measured macrophages. And when you looked at those 7 cases, all 7 of them were lipid-laden, as was seen in the mouse tissue. Other considerations I think that are important to consider with these is that first, we have absolutely no real robust data on how many patients voluntarily stopped vaping because they had too much phlegm, or they had a cough or a sore throat, or otherwise irritated them, and they just stopped vaping. One of the things that I think is important also to consider is that the practice of vaping has evolved from the early days. And so we monitor websites on a fairly regular basis where there is advice given to inhale and hold for long periods of time. This is particularly important in a cannabis culture or consuming other drugs than nicotine, drugs other than nicotine, where users understand that if they inhale and hold for longer periods of time than they might when just vaping nicotine, that you're giving more time for that drug to enter into the lung tissue. And so therefore, what we're doing potentially is exacerbating, increasing the amount of time that that aerosol is in the lung tissue as compared to just a nicotine-only instance, or people who don't take drugs other than nicotine. One of the other pieces that I think is important to consider here is that the pod mods lead to issues of concealment and issues around concealment, meaning that users will vape and then hold it and then find a moment in which they can exhale into their sleeve, or in a situation in which they're not around a lot of people. The point is that potentially the pod mods and the issues around concealment are also leading to longer times that an condensation aerosol is held in the deep lungs. In addition to just thinking about behavior, we also have to consider the e-liquid composition and how those change in terms of all of the chemicals that are used for flavorants. Does the Nic salts with the organic acid exacerbate the lung tissue as well? And then one of the things that we consider is when you are also inhaling something like ethanol, is that also going to lead to some issues as well in terms of cellular health? So the mechanism is still not elucidated. There's still not a single chemical compound that goes across all the cases in the nation. One of the things that I think about very regularly is that PG and VG are hygroscopic, meaning that they have a tendency to pull water out of their environment, whether that is going to be from the air that it's surrounding them or in the deep lung tissue. We know that deep lung tissue has a layer of water and surfactant. So if we're already irritating the deep lung tissue by drying it out, and then other chemicals and metals can then exacerbate that immune response that could also already be mounting because the deep lung tissue is dried out. One of the things that we also have an appreciation for when we're thinking about behavior is that we have to ask these patients the questions about how often do they vape. And so many young people will call their e-cigarette their 11th finger, meaning that they never set it down. They're constantly vaping on it. So in addition to the inhale and hold, now the volume of aerosol that they're inhaling is compounded by the fact that they're always vaping. Just this past week, there was a manuscript released from the BMJ. First author is Gotts, and whereby the mechanism is still unknown. This is an excellent review paper that goes through lots of issues around vaping and e-cigarettes. So it's an excellent review paper, in my opinion. Other things I think we also need to consider. We have seen a rash of what I would consider, frankly, poisonings across the United States from people vaping CBD products, or whether those are e-liquids or oils that get added to an e-liquid. And so we've seen these rashes arise from Atlanta to North Carolina, all the way across the states to Utah. And so there have been hundreds of these kinds of cases reported. So a handful of victims reached out to my research laboratory with information as to their situation, right? Meaning that they went to buy CBD-based products. And so what you see here are people who went looking for CBD to use as some kind of therapy for some medical intervention, whether that be to relieve anxiety or use it as pain relief. So you'll see here that two elderly ladies went to a local pharmacy or a store that they believed would be safe and bought CBD products, and then devolved into hallucinogenic episodes. So when we got these e-liquids into the lab and started taking a look at what they contained, We, in 1 to 5 of the 8 samples that we had, we found synthetic cannabinoids. And of the remaining 3, we're fairly confident from our investigation so far that they are synthetic cannabinoid, but we're not confident yet as to which Syncan it actually is. And so these people went into shops that they thought was safe. That they believed that they were going to get a high quality product. And this is a picture of one of the vape shops that one of the victims went into, again, with the presumption that they were going to be buying safe products. So my concern about these victims and others like them is that they don't know where to turn. They're not going to call the police. They may or may not mention something to their physician. And so they're turning to online forums to find some kind of validation or support for their experience, because the Food and Drug Administration has yet to really have a robust reporting mechanism. Now, since then, in light of the recent episodes, we have seen a reporting mechanism get set up through the CDC. But at the time, months ago, these patients didn't have anywhere to report their adverse reaction to the CBD product. So with that said, thank you for your attention. Thank you for what questions you're going to send me through the Indus Network. And I look forward to engaging you. Thank you.